Laws of exponents. In this video, I want to go over negative exponents. Remember, an exponent is a small number written at the top right of a base known as a number or variable. Exponents is just repeated multiplication, meaning the base is multiplied by itself a certain number of times. Now, a negative exponent just moves the location of your base. Remember that whenever we are talking about whole numbers, we can have an imaginary number 1 underneath the whole number. Because I have 5 to the negative 2, this negative is going to move it down to the imaginary spot underneath the 5, a bottom, and it's going to create a fraction. So really, I have 5 on the bottom, and I need a placeholder. So I'm going to have an imaginary 1 on top to save the space so that I know it is a fraction. And now I can actually simplify the 5 squared, which is just 5 times 5, giving me the 1 over 25. So a negative exponent is just going to move its spot. Now, there are different ways to deal with negative exponents in a problem. You can apply all of the different properties. So you can use the product property in this case, simplify, and then deal with your negative exponent to move its spot. Reason for doing this is because sometimes within the process you can have different numbers and your negative exponent can end up in different spots. Doesn't necessarily mean it's going to end up in the bottom. It could end up on the top once it's all simplified. Or you can deal with your negative exponent and then simplify your problem. For example, if I were to just use the product property and add my exponents here, same base, we're multiplying, so I can add negative 8 plus 3 is equal to negative 3. So I end up with 2 to the negative third power, which means I need to simplify this into a fraction to get rid of the negative. So I have 1 over 2 to the third power. 2 to the third power is 8, which gives me the 1 over 8. Or I can go ahead and deal with the negatives first. So I'm going to move this 1 to the bottom because it is a negative. So I'm going to have 2 to the fifth power stays on the top, but now this is going to go on the bottom. And now I have to use my division property, which says I need to subtract. Well, 5 minus 8 is equal to negative 3, which takes me back to what I just did before. To make that 3 positive, I moved it in the bottom. Or you can know that the bigger exponent is at the bottom. So when you subtract to keep it positive, you need to keep it at the bottom. So when I simplify this, I can say 2 is going to stay at the bottom. And 8 minus 5 is 3, so it's going to stay at the bottom. And then simplify the 2 to the third power. So there are different ways to deal with negative exponents, which can feel confusing when there are different options you can take. So here I have 2 examples. I want to simplify the expression, meaning that at the end I do not want negative exponents. I'm actually going to keep the negative and simplify at the end. So I have a power to a power here. Power to a power says to multiply. Negative 4 times negative 3 is positive 12. So now I have 2 to the 12th power times 2 to the negative 3 power. The reason I chose to keep them is because notice how my 12 became positive anyway. Now I have 2 to the negative 3 power times 2 to the 12th power. Because we have same base and we're multiplying, I can add exponents. So negative 3 plus 12 is 9. So I have 2 to the 9th power. And by keeping my negative exponents just where they were and following the rules before, I actually simplified. I ended up with no negatives anyway. In my second example, I have 2 to the n times n to the negative 4 power, all of that raised to the 4th power. So I have power to a power, so I'm going to simplify that. So we have 2 to the 4th power. We have the first n to the 4th power, and then we have the second n raised to the 4th power. 2 to the 4th power just means 2 times itself 4 times. So that's going to simplify into 16. N to the 4th power is just n to the 4th power. Nothing we can simplify as of yet. Power to a power means to multiply the exponents. So negative 4 times 4 is negative 16. And now I still have something extra to do because I have n and another n. This is the product property. I am multiplying these n's, so that means I can add my exponents. So 4 plus negative 16 is negative 12. Now I have one last step to simplify because I don't want a negative exponent. That negative 12 just means to move the n to the bottom. So my final answer is going to be 16 over n to the 12th power.